In this video, I want to talk about molecular formulas of alkanes. As we know, alkanes, the structure of the alkanes are purposely written as chains of CH2, which they are called methylene groups, terminated at each end by a hydrogen atom. This is the general formula for the unbranched or straight chain alkanes. So it looks like some chains of CH2 groups connected to each other. These alkanes differ only by the number of methylene groups in a chain. If the molecule contains n carbon atoms, it must contain 2n plus 2 hydrogen atoms. So if we have n carbon atoms, we will have 2 times n plus 2 hydrogen atoms. For example, if n is equals to 2 for carbon atoms, hydrogen atoms will be 2 times 2 plus 2, which will be 6 hydrogen atoms. So as you see here, there's a list of the first 30 alkanes. So the first 20 and the 30 as you see here, we have number of carbons. It starts from methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, and the rest as you see here. On the third column from the left, you can see the structure, and as you see here, from each side, you start from hydrogen atom, and the rest of it is going to be repeating methylene groups, which is CH2. And also in the next column, you will see the formulas of each of them, which is CH4, C2H6, C3H8, and the same for others. So as you see here, the chemical formula, the general chemical formula will be CnH2n plus 2. For example, let's take a look to C8H18. So in this case, n is 8, so number of hydrogen has to be 2n plus 2. So 2 times 8 plus 2 will be 18. So that's why we have C8H18. And you will see other properties such as boiling point, melting point, and density. So as you see here, by increasing the number of carbon atoms, we are increasing the boiling point and also the melting point of the chemical formula. And as you see here also, the density is increasing as you increase the number of carbon atoms. So as we said, the general chemical formula for alkanes are CnH2n plus 2. So that's the saturated forms of alkanes, unbranched. So although we have derived CnH2n plus 2 formula using the unbranched in alkanes, it also applies to branched alkanes as well. An isomer of one of these N alkane has the same molecular formula. So the molecular formula doesn't change for unbranched or branched alkanes.